Hello viewers, in today's class we are going to discuss a very important problem from definite integrals in which we have a combination of greatest integer function and signum function. And in this lecture we'll see how we can easily evaluate this integral in which we have -1 to 1 and the integrand is e raised to the greatest integer of minus pi and signum of x square, right? So we'll see how we can solve this integral by making use of the definition of signum function and the greatest integer function, right? So let us first call this integral as I. Now let us first define the signum function. So here we have signum of x square. So signum of say y is defined like this. Signum of y takes the value plus 1 whenever y is greater than 0, and signum of y is equal to 0 whenever y is equal to 0, and signum of y is negative 1 whenever y is less than 0. So this definition may be utilized to evaluate or first to simplify this integral, and then we can use the definition of greatest integer function. Now see here the limits of integration vary from x is equal to -1 to 1, right? So here we have x is equal to -1 and here we have x is equal to 1, and here we have a signum of x square, right? Now see, whenever x varies from -1 to 1, or we can say that whenever x take any value between -1 to 1, then x square is always greater than or equal to 0. So now between -1 and 1, we have the integer 0, right? So here we can divide this integral, or we can split this integral as a sum of two integrals, right? We can also use one important property of definite integrals to simplify this integral, but here we'll take this method, right? So here we have 0 between -1 and 1. So let us first write the integral number 1, that is I1 from -1 to 0. Then we can take the second integral from 0 to 1, which is I2, right? So I1 is from -1 to 0, and we have e raised to greatest integer of minus pi signum of x square, and here we have dx, and then we have 0 to 1. I2 is 0 to 1, e raised to greatest integer of minus pi signum of x square, and here we have dx. So now see, when x goes from -1 to 0, so when x belongs to the interval -1 to 0, then this x square is always positive, right? So whatever be the value of x between -1 and 0, x square is positive because this is a square term, right? And similarly, in the second integral, we have the values of x from 0 to 1, right? So here also the value of x square gives us always a positive value, whatever be the value of x belonging to the interval 0 to 1, right? So we can see that in both of these integrals, signum of x square is equal to positive 1, right? Because this quantity y is greater than 0, and here we have y as x square, right? So x square is always greater than 0, whatever be the value of x lying between -1 to 0 or 0 to 1, right? So x square is always greater than 0. So signum of x square always gives us the value positive 1. And now we can write these two integrals as minus 1 to 0 e raised to greatest integer of minus pi times 1. And here we have 0 to 1. Then we have e raised to minus pi times 1, and here we have dx. Now since here in both the integrals we have the same integrand or this value, so we can now simply write minus 1 to 1 and e raised to greatest integer of minus pi, right? Here we have greatest integer of minus pi, here also we have greatest integer of minus pi, and here we have dx. So now the approximate value of pi is equal to 3.14, right? And here we have greatest integer of minus pi, and the greatest integer of minus 3.14, which is greatest integer of minus pi, that is equal to minus 4, right? By definition of greatest integer function. So the greatest integer less than or equal to a negative of 3.14 is equal to minus 4, right? So now this integral is minus 1 to 1 e raised to minus 4, and here we have dx. So now e raised to minus 4 is a constant, so we can take it outside the integral. We have e raised to minus 4, integral from minus 1 to 1, and here we have dx. So e raised to minus 4, the integration of dx is x, limits are from minus 1 to 1. So we have e raised to minus 4, 1 plus 1, substituting the limits and taking the difference. So 1 plus 1 is 2. So 2 times e raised to minus 4, which can also be written as 2 divided by e raised to 4, right? So viewers, the value of this integral is equal to 2 over e raised to 4.